All right, guys, we're back. I'm sorry for the interruptions, but we're back and we're going to learn how to do an angle bisector now. Okay? So, a couple things with the angle bisector. Here, here we go, and we know that an angle consists of two segments or rays that are joined with a common endpoint. So this is my angle. This is not my 140-degree angle, but let me just show you. Okay, first off the bisecting component of it, and then we'll look at how we determine the exact value of the angle, that the exact degree. Okay, so here's my angle. Now, of course, the angle here is flexible, which means, of course, I can I can alter its size. In fact, uh, let's just find the angle measure here. So we're going to select the points in the order A, B, C, as I did. We're going to measure the angle, okay, and that's going to be there, and you know, whatever measure it is fine, okay. I can't expect necessarily that this is going to sweep around and I can draw an exact 140-degree angle. In fact, it's very aggravating trying to do so. So there's obviously a better way. So, but let's show you the bisector now. So what I do is I select the angle again in the order. Remember, the order must always contain the vertex in the middle. And then I choose to construct the angle bisector. Okay, so the angle bisector comes in. I would like to probably put a point on that. So with the angle bisector selected, I would like to construct a point on the bisector. I'll give that, you know, coordinates. Uh, um, rather give that a name, and then I should know that the measure of the two angles should add up to this total. So let's just run you through that. Okay, again, I'm going to select the two angles, angle A, B, D. Okay, um, and I'm going to measure that. I don't think I selected point D. Here we go. Angle ABD. Measure the angle. Okay. D, B, C. Measure that angle. All right. And then, of course, you can see that they're equal. And, of course, they're always going to be equal. Uh, Again, I can sweep this around. They're always going to be equal. And they're always going to add up to this all-inclusive angle. And, again, if we want to illustrate that, then we go and say, well, okay, let's do the number, calculate. I want this angle plus the second angle, and you can see it's always going to add up to that all-inclusive angle right there, which is justifying that we have what we call an angle bisector. Okay, so we have the angle bisector. Now, okay, how do we construct a 140-degree angle? Okay, well, all right, just let me pull up another page to show you how we're going to construct an angle of a given size, okay? So we're just going to add a blank page here, all right? And now, okay, so what I want to do is I'm going to draw one ray of the angle, okay? Now, what I want to do now is go up, select, and get my selector tool, select one endpoint, okay? And from the transform menu, I want to choose mark center, the first option, mark center. And you can see that does that little thing there, okay? I could also mark center likewise by double clicking on that point, okay? So then that means that's the center of rotation. So I want to choose that point. I want to choose my segment as well as the other endpoint. And now I want to go to again to the transform menu, and I want to rotate this, and then I can rotate it by however many degrees I want. I believe we said we want 140 degrees. So there's my 140-degree rotation. Okay, so and then click on rotate, and that's locked in. So now locked in is to imply that there's nothing I can do to, I mean, I can reposition that angle, but it's always going to be 140 degrees. I can't do anything to change the angle measurement, okay? You want to prove that it's 140 degrees, select, select, select. Again, vertex point is the middle point selected. Measure I guess I didn't select the 3 points, measure, okay, the angle, okay, and then, and of course, that's 140, like I said, and it will not change, okay? And again, select the 3 points for the angle, and then go to the construct menu, and the angle bisector is what we want, okay? And so that will be a perfectly bisect 140 degree angle, okay? Let's go and run you through the last sketch. Construct an equilateral triangle with sides 16. Okay, actually I might change that to 10. Might be a little bit too big. So we'll go to sides 10. So now, how am I going to make sure it's of sides 10? Well, simple enough would be to go to the graph and work off of the graph. Okay, so we'll go to the grid, and we will just mark off 10 units. So we could go anywhere from, in fact, it might be better if we just turn the snap points on, okay? And then what we want to do is measure out 10 units. So I'm going to draw a segment. Let's start here. It'd be convenient, and draw it out 10 units long. Okay, so that's my 10 unit length segment, okay? And that's guaranteed to be 10 units of length, okay? So what I can now do is I really don't need the grid, so I'm going to go back, and I'm going to choose hide the grid. In fact, I want to hide the grid and the axes, so I'm going to select my axes as well. I'm going to do a right click. I'm going to select hide the axes, okay? I'm going to do the right click again, hide the axes once again. These points I can get rid of too. Hide the unit point, hide the origin point, okay? All right, so now an equilateral triangle, of course, is a triangle with all sides equal and all angles equal. I think most people will know that an equilateral triangle that has all angles equal, and if all the angles of a triangle add up to 180, that means they're each 60. So what I want to do is I want to do that rotating again. I'm going to select that point, okay, double click on it so I mark the center, select the segment and the end point. This time I'm going to go to transform. I'm going to rotate by 60 degrees. 60 degrees is the default. It seems it went right to it, so that's good. Rotate, and now I can draw my other segment to finish off the triangle, okay? And it looks like I've got snap points on, so I got to come back. I got to turn off my snap points, okay? So connect, okay? And this will make a nice little design for you, as you'll see, okay? Construct. In fact, what I'll do, let's do a little color code to it. Let's select this and select the 3 vertices and a triangle interior. So that's a color, and you can choose a color that you want, okay, red or whatever, okay. Now we'll go and we will select the sides, okay, select the 3 sides and construct the midpoints. It looks like we didn't get those sides selected, okay. So select the 3 sides, construct the midpoints, and now join those with another triangle which is going to be similar to the original triangle. Let's do another color code on that again. You know, select the segments, select the segments, select the segments, the vertices rather. Construct the triangle interior in a different color, whatever you like, okay? Okay, and yellow, did I choose yellow? Yes, I did, okay. Do it 2 times again, okay? So we get kind of a neat little design here. Again, I'm going to select the sides, select the sides, select the sides, okay? Construct the midpoints, and then join those midpoints with sides to form yet another equilateral triangle inside of the existing one. Select the vertices Okay, I gotta go to my selection tool here. Select the vertices, and construct the triangle interior and choose yet another color of your choice, of your choosing, okay? And then I guess we do it one more time. I'll leave that up to you to do that. So that's your equilateral triangle with constructed that's for your third assignment, okay? So there you have it. You can watch those again. We'll be building those in class tomorrow, and then we'll be uploading them through Apera, okay? So watch this again and again if you need to, okay? But I'm going to ask you to do very similar figures in class, so you need to watch it so you know how to proceed with it, okay? That's it.